Let's look at the strength of acids and bases. What I want to show you is what makes a strong base strong and a strong acid strong, and what makes a weak base weak and a weak base weak. Strong acid, as you can see, HCl is a strong acid. It's a strong acid because it dissociates completely. So if we could put some relative percents on here, that after you would put hydrochloric acid in water, pretty much 0% would remain as HCl, whereas 100% would dissociate into hydrogen and chloride ions. You can see if we look at this slide coming up here that let's see, this is a weak acid, so just a second here. There's a strong acid. So right down here you can see that this HA, that would stand for HCl. And the red ones in here would be your HCl. And well, you don't see any HCl in there, excuse me. What happens is when you put HCl in water, it forms, the A would be your chloride ion, and then H3O would represent H+. And so if you notice that all these red ones right here, these are all your H+. And so if you notice, you don't see any HCl because all of it has dissociated. Okay, going back. Alright, now let's compare that to a weak acid. And when you have a weak acid, weak acids only partially dissociate. So if you have this acetic acid right here, CH3COOH, if you put that in water, what you would end up having is you would have about 98% of it would stay together as your acetic acid, and only 2% of it would dissociate. So let's see here if we can make this go ahead here. So here's a weak acid. So here, this gray one right here, that's your acetic acid, and you can see that most of it has stayed together as acetic acid. And over here, this red one again would be your H+, and over here would be your acetate ion. And so you can see most of it stays together as the acetic acid when put in water. Only a small fraction of it actually dissociates. Alright? So let's go back here. So what makes a strong acid strong? Complete dissociation. What makes a weak acid weak? Only partial dissociation. The same thing is true for bases. A strong base has complete dissociation, whereas a weak base only has partial dissociation. So if you look here, let's see, I think there's a couple pictures here. And so here is your base. Those would be the gray ones, and you can see it's a weak base. And so you can see that a weak base only partially dissociates. Most of it stays together, as the gray shows, as the base, where only a few actually form your hydroxide ions. And so a weak base, you have only partial dissociation. Whereas when you have a strong base, so here is your strong base right here. I don't want that. So when you have a strong base, you have most all of it, or if not all of it dissociates, and so all these blue ones that you see here, all those are your hydroxide ions. So a strong base is characterized by complete dissociation. Notice there's none of this left when you put it in water. Alright? Complete dissociation. So to review, what makes a strong base strong? You have complete dissociation. And what makes a weak base weak? Only partial dissociation.